right, we're Team 19 and we're doing a DfM analysis and redesign of a Class A fire extinguisher. To describe our product a little bit more, a Class A fire extinguisher is a product that is used to control or extinguish generally wood or paper fires by dispensing a chemical fire suppressant from inside of a pressure vessel. Generally, this is done via human operator actuating a lever on the top. To get into the components a little bit more, here you can see the exploded CAD view of the fire extinguisher. There are 13 individual components, excluding the fasteners that hold parts together. For primary and secondary consumers, our primary consumers are going to be facility and building managers, such as apartment building owners or company owners. And our secondary consumers will be homeowners and for such as residential homes. The respective product volumes will be 13.8 and 5 million for the primary and secondary consumers. For functional analysis, this is our FAST diagram. The task function is suppress flames, and then we have two primary basic functions, dispense suppressant and enable portability. The supporting functions that demonstrate how the primary basic functions are achieved are to the right of those, as well as the predefined supporting functions also have their supporting functions to the right as well.
All right, here we see two fishbone assembly sequence diagrams. On the left side, we see sequence number 1, which is the top-down assembly with the valve as the base part. And on the right side, we see sequence number 2, which is the bottom-up assembly with the tank as the base part. And on the next slide, we compare these two fishbone diagrams, and we concluded that sequence 2 would likely be the better assembly diagram, mainly because instead of sequence 1 and where you have everything connecting to the valve and then you attach it to the tank, everything is more streamlined and in sequence. And we rated this from 1 to 3 for each column, 1 being the worst and 3 being the best. And so on the next slide, we mapped out the function component in a matrix here. So on the top column, or in the top row, we see the functions from the FAST diagram, and on the left side, we see the components of the fire extinguisher and how those interact with each other. It's also continued on the next slide for the remainder of the parts. And that is our function component mapping matrix.
Moving into our bill of materials, for taking the total unit cost for each part, we looked at the material cost, processing cost, assembly cost, and tooling cost of each part. However, for some of our parts, like the spring, pressure gauge, housemates, and rivets, we are not going to have a processing cost or tooling cost because we're going to purchase these directly. And we found those prices by looking at bulk prices. And some assumptions for filling out this bill of materials. We assumed a $20 an hour wage, $60 an hour machine operating cost, an automatic feed rate of 25 millimeters a second, and then an injection mold cost of $22,500 to $25,000, 33-cent extrusion cost per kilogram, $200 die cast cost, and a 50,000 batch size. Looking at our total unit cost, we ended up with about $39.64, which, when taking into account the added cost of the CO2 and agent that's going in the fire extinguisher, that ends up being $54.64, or about 64% of retail price. So using the total unit cost for each component and mapping that against the importance, we can create this diagram that shows which components can be left as is, which ones can be eliminated, and which ones can be redesigned.
Moving into our product family design section, we start with the functional differentiation table. The majority of our functives are the same for both our primary and secondary customers, as seen on the left side, while the only differences in the secondary design is that it is more accommodating for hands, releases differently from fixture, and stores less suppressant.
Next, we created a component commonality table to find which parts can be made modular for different customer groups. In order to make this table, the function component mapping matrix and function differentiation table shown earlier were used. The 3 components we found that could be made modular are the handle, tank, and trigger.
For the secondary customer, our first modification is adding grooves for your hand on the handle labeled as 1 and lengthening the handle and the trigger in order to provide a more comfortable fit and guidance as to where to place your hands on the fire extinguisher. The second modification is a smaller size using a scale factor of 0.75 in all directions while still keeping the same modular interface, allowing more convenient storage in homes and the opportunity for more to be placed around the house. To accommodate for the modifications previously mentioned, we have added modularized interfaces to allow parts to be switched on and off, the first being a modularized attachment to the valve of the handle and the trigger, so that both the primary and secondary designs fit on the same valve design. Secondly, the attachment of the valve to the tanks is also modularized by a screw design between the valve and tank that is the same constant size for both, allowing the tanks to be interchangeable.
Lastly, we have two assembly sequence diagrams. The bottom diagram shows the assembly order after delayed differentiation, which should mitigate risk by accounting for market demand of this product. The red circles indicate the modular components of the fire extinguisher. This concludes our presentation. Thank you.